Welcome to the .NET MAUI Cartesian Charts tutorial. In this video, I will demonstrate how to predict stock trends using the AI service in the Syncfusion .NET MAUI Cartesian Charts. I open an existing MAUI application. Here, I have already configured the .NET MAUI Cartesian Charts control and specified the candle series to display the stock data. To learn how to add the .NET MAUI Cartesian Charts control to your MAUI application, watch the video linked in the YouTube card above or the description below. Now, I run the application. You can see that the stock data is displayed in the candle series. Now, I will set up a user interface with an AI button to trigger AI-powered actions. Within the grid, I add a button control with a click event to initiate stock predictions. Next, I will show you how to display forecast stock data when I tap the AI button using the AI service in the .NET MAUI Cartesian chart. So, I open the NuGet Package Manager and switch to the Browse tab. I search for the Azure AI OpenAI NuGet package, select it, and then install it in my project. In this example, I will be using Azure OpenAI. However, you can choose any chat completion service. If you decide to use Azure OpenAI, make sure that you have access and have configured deployment through the Azure portal. To securely authenticate Azure services without storing API keys, I have installed the Azure Identity NuGet package. Additionally, I installed the Microsoft Extensions AI OpenAI package, which allows for seamless AI integration into applications. Once these packages are installed, I create a class called Azure OpenAI Service to handle interactions with Azure OpenAI. I begin by declaring three constants: endpoint, which specifies the Azure endpoint URL for API calls; deployment name, which refers to the name of the AI model; and key, which is the API key for authentication. These values are essential for connecting to Azure OpenAI. Next, I add two internal properties: client, which represents the AI model interface, and chat history, which stores the conversation history. To ensure that the application can communicate with Azure OpenAI services and handle AI requests, I create a method named getAzureOpenAI, and I call it in the constructor. Within the try block, I create an instance of Azure OpenAI client using the provided Azure endpoint and API key. Then, I store the created OpenAI client instance in the client property. I create a helper function, generatePrompt, that generates a formatted prompt to send to an AI model for predicting future stock prices based on historical data. In this method, I create an empty list called items to store stock data. I iterate through the historical data in reverse order and add each stock entry to the items to ensure that the latest stock data appears first in the prompt. The prompt instructs the AI to predict the next 45 stock movements. I iterate over each model object in the historical data list, formatting and appending the stock data from each model instance to the prompt, including the stock prices for that date. Additionally, I append the instructions on how the model should format its response, and then return the updated prompt. Next, I create a method called getAnswerFromGPT that sends user input to Azure OpenAI and returns the AI-generated stock forecast. Within the try block, first I check if the chat history and client are initialized. Then, assign the user prompt to the chat history to store the user input for AI processing. Next, I call the completeAsync method to send the chat history to Azure OpenAI. After receiving the response, I return a structured list of predicted stock values using the convertToCompaniesModelCollection method. In this method, first I check if the data string is null or empty, and return an empty collection to prevent processing errors. Next, I initialize a collection to store the stock data, and split the AI-generated text response into separate lines. I use a for each loop to iterate over each line, and skip any empty ones. I split each line using a colon as the separator. Then, check if it divides into exactly 5 parts. I parse the first part as a date, and convert the high, low, open, and close prices into double values, trimming each string to clean it before parsing. After that, I create a new model object with the parsed values and add it to the stock data to store the structured data. Finally, I return the collection of stock data. Next, I move to the getAnswerFromGPT method. If any failure occurs, return the generateDataSource method to generate the stock data. Now, I navigate to the ViewModel class to implement the generateDataSource method. First, I retrieve the existing stock data. Then, find the latest stock data entry and set the initial opening price based on the highest closing value. I define the end date as 45 days after the starting date. Next, I initialize a random number generator to create fluctuations in stock prices. I then create a new collection to store stock data and add the first available stock data entry to maintain continuity. I iterate from the day following the starting date to the end date, incrementing by 1 day at a time. Within the for loop, I retrieve the last added stock entry from items collections to calculate trends. I generate the opening price with random fluctuation, and then compute the high and low prices by slightly adjusting the opening price. I set the closing price and update the initial open price for the next iteration to create a realistic trend in stock prices. I create a new model object with the generated values and add it to the collection of items. Finally, return the items collection. Next, I define a property of type observable collection to store the predicted stock data and initialize it in the constructor. I create a method, addRange with delay async, to dynamically update the forecast data, smoothly adding each prediction with a delay. In this method, I iterate through each item in the forecast data collection. Before adding each item, let me check if the stop update property is set to true. Then, I set the isRunning property to false and exit the loop using a break statement. If updates do not stop, I set isRunning property to true to indicate that the process is active. Next, I add the current item to the forecast data collection, which automatically updates the UI. Lastly, I introduce a delay before adding the next item to create a smooth, step-by-step update effect. In the AI button clicked method, I check if the isRunning property is set to true, which indicates that the forecast is currently in progress. I signal the system to stop the update and introduce a delay to ensure a smooth halt. Next, I clear the forecast data in preparation for new predictions. I create an Azure OpenAI service instance to interact with OpenAI and retrieve stock data from the view model. I retrieve the last 40 items and convert them into a list for easy processing. Then, I generate a prompt based on the most recent 40 stock data points to guide the AI in making a forecast. I send this prompt to Azure OpenAI using the getAnswerFromGPT method, which returns AI-generated predictions. Once I retrieve the AI-generated forecast, I resume the update by setting the stop update property to false. Before adding the new predictions, I clear the previous forecast data once more to ensure a fresh update. I add the AI-generated predictions to the forecast data, with a 300 milliseconds delay between each entry, to create a smooth UI update experience. Finally, I return to the main page XAML and add the candle series to display the AI-generated stock forecasts. In the date-time axis, I add a plotband and the start date to visually distinguish between the historical and forecast data. When the application is loaded, I click the AI button. You will notice that the forecast stock data is displayed. Let me wrap up this video. You have learned how to predict stock trends using the AI service in the Syncfusion .NET MAUI Cartesian Charts. If you would like to see this example's working code, download it from the GitHub link in the description below. I have also included a link where you can check if you qualify for our community license, which gives you a free license key for our entire .NET MAUI controls. If you found this video helpful, click the like button and subscribe to our channel to watch more videos like this. Thanks for watching.